hello. Thanks for having me. Okay. I want to just introduce myself a little bit. So I'm Merab Kutalia, AndroidGD, and you can find me with this Twitter handle on Twitter and LinkedIn and everywhere else. So if you have any questions or I'd say suggestions how this testing thing can be improved somehow, you can just hit the message. So let's go and dive in the actual topic itself, the Android UI testing and the challenges. It is more like an overview talk and the introductory for those who don't know the Espresso framework. But okay, let me do a quick review of these powerful tools which are offered by the Android itself. And the first tool is the UI Automator. It's a very powerful tool, but very specific as well. Mostly it is used by the test automation engineers and for the reasons to test the application behavior. It's like to view to test your application from the top view, how it interacts with other applications, how it shares the intent to other application, what is the result, if the web view is loaded, what is the content in the web view. For the primary purpose is the end-to-end testing, and that's why it is mostly used by test automation engineers instead of the developers. But on the other hand, we have a very powerful framework, Espresso, which is actually used by the developers, and it lives with the source code, and you can just simply write it with the along your application source code. So you develop application and then you craft your end-to-end test and the UI test. So even Espresso has several different scenarios and the abilities. So I want to review this in my talk. So why Espresso? And Espresso is not the new shiny thing. It's quite old. I guess it's from 2015, but still it's very powerful, and it gives us the ability to test the application in very different ways. And the modern new toolkit, and we will talk about this, like fragment scenario, activity testing scenario, gives us the ability to test very specific fragments and activities in isolation. So that's one of the main benefits of Espresso. And the bottom line is that it's very fast compared to the Appium and other options for the test automation. So of course it runs on the device and emulator because it's an instrumented test still, and we need it. But there is the library, I don't remember the name, from the cache app, if I recall it correctly, which allows to run some of the UI tests without the graphic interface of the emulator. But I need to check it out. So I'm not confident with that information, but still I saw it several days ago. So stability and the high speed is the main features of the Espresso, because the flaky tests are the pain point of the developers and testers, and it is often the main reason why the test suite, the actual test pipelines fail. So Espresso is much more stable than any other competitors, but still it is a part of the UI test, and we don't have the 100% of stability because it's a UI, it's a different manufacturers, different devices, different OSs, and so on. One of the best features of Espresso is also quite old feature, but it still shines for the newcomers, is the test recorder. So you can actually run your application and run the test recorder from the Android Studio, and then you can just click on any button and do any action, and it will generate the respective Java or Kotlin code. So this is really great tool for two reasons. First, I mentioned for the newcomers, and second, for those who want to migrate some part of the project from the Appium side or for someone to the Espresso. And of course, I mentioned the tooling. So in tooling, mostly we talk about the uh, Android Studio. So Android Studio is a great tool, great tool to do the Android and everything about the Android, including Espresso and so on. And we will talk about a little bit about the scaling, because the Espresso gives us ability to, not the Espresso, but the type of the test we can write on Espresso to run on the device firms like Firebase Test Lab, and the AWS has its own device test farm. So it gives us ability to emulate our tests on very different devices and to get the results quickly. So let's deep dive a little bit more in Espresso, how it works and what are the main characteristics of the Espresso. First of all, it's like a regular test, like a JUnit or any other framework. It just needs these three main components, which is some kind of matcher. We need to find the view in that case to match somehow with the ID, with the text on it, with a hint, or I don't know, anything to match some kind of view, to grab it, and then they execute an action on it with the view action. So it's a click, double click, long press, and any other action. So we grab the view, then we click on the view, and then we need to check the actual operation. So what was happened? So in that case, we use the view assertion, and it's just works with the views, and we can check if the view is hidden, if the view is shown, if the content, the majority of content is visible, and so on. So this is a cheat sheet for the Espresso, and it says that it's 2015. It's quite old, and it's from the official Android documentation. But let's dive in quickly for a moment. So as I mentioned, we have three main components: view matcher, view action, view assertion, and it just method chaining. So we declare that on view, we find view with the methods like with ID, with text, with tag, if with a hint, with the content description, and so on. Then we need to perform some kind of action, and we take the actions from this blue table, like click, double click, long press, and even press the menu key, close the keyboard, and so on. We have gesture support, and also we can work with the text. And keep in mind that all of these are extendable, and you can write any custom extensions you want. And then we need to check the actual result, like if it matches, if the layout overlaps the other layout, if it's left to the something or to the right. So there are plenty of options. And also the bonus part, it works with the intents as well. In intents, I mean, if your activity opens the different activity with we have the functions like start activity with result, and we wait for the results, so on. So we can check the actual intents there in the bundle, what's in the bundle, check the component name, check the package name, check the scheme, and this is very useful using the deep links and so on. So there are plenty of options to play with, but we have very limited time, so it's very hard to really deep dive and do it like a workshop. But why I chose this talk, the Espresso, it's like everyone talks about the Compose today, and it's really great. And the UI testing in Compose is really great. But we should not forget our legacy code or our existing codes, which is the majority of the code is on the Android view-based system. So we still need to test those applications, and those applications still grow and grow. And even if we use the Compose like the hybrid model, it's Compose plus Android view-based system, we still need Espresso for this. So it's not like this, like that Compose toolkit can give us the ability to test the old views. No, Compose toolkit is for the Compose, and for everything else we have the Espresso. So using Espresso, we can also test this hybrid application. So that's why the Espresso still is popular and will be popular. So here is the example, just simple example, which we can just explore as a demo as well. So let me just share the whole screen. Sorry. So here I have the basic sample. It's from the official Android testing samples, so you can grab the copy from the repository and test and play with it. So let me show the application first, how it looks like, and then how we can test it. So applications. So applications usual behavior is like we have some kind of input here. Hello. Okay, like this. So hello, I'm Tato. I click the button, so I check the text, and we have the very simple text view there and the changes. And we have another action that we can open activity and change the text there. So we can pass the intent there and change the text, and it writes this. So we need to test here to test in the same activity and to test in a new activity. And for this we have the Espresso, and we have the syntax like this, that on view we grab the edit text with the ID, we perform the action, we type the text, and then close the keyboard. Hence the method chaining there. So it's a vararg method signature, and it can get any view action. And then we check that we also grab the button. So we use view matcher here and perform the another action, which is a click. And then we check the actual contents here if it's equals the string which was initially entered by us. And another test is like do everything else, but to check the another ID in a different activity. And Espresso Espresso automatically weights the activity transitions and so on. And we'll talk about this a bit later. So let me just run this test and let's just monitor what's going to happen. So on the Android side, Android Studio side, we have very powerful test runner, like shows what is the emulator, what's happening, what is the device info, and so on. Sorry, my voice version is too low because it's much faster during the screen sharing than any new version. So sorry for this. Okay, so both tests completed successfully, and just to show how descriptive the error messages are, let me share, change this test. Okay, just run this. Okay, Gradle is building. This is the part I hated. And it's failed, of course. And we have very descriptive message what was failed and what was the main problem with it. So it was we were waiting the different kind of text, and we got the other kind of text, and it shows the current state of the text view, if it's visible, what is the size, if there's some kind of focus, and so on. So yeah, that's for now. Just let me share the presentation. Okay, let's continue. Okay, how Espresso works and what is the underlying mechanism to follow all the test cases we need. So there are three major some three major conditions, and yeah, if you see the async tasks there, don't blame me. It's from the Android documentation official, and yeah, we will discuss why. So, so first condition is that the message queue should be empty. So what is the message queue? Message queue is the part of the main thread, and it just tracks our actions on the thread. So when I said the Espresso runs with the application on its main thread, I meant that when we do some kind of action via Espresso, it goes to the same main thread and waits if there are some kind of action already. If no, then we can just dispatch our Espresso action. So if we swipe on the Espresso test, it will swipe in the application, but after the any other actions is done on the application. For example, if we have some kind of loading in the application, or I don't know, some kind of automatic uh, clicks, or we disable button and so on, and then we post the action from the Espresso test, it will dispatch and it will finish the last one, because every other action was in the queue, in the message queue, actually. So that's a basic principle. It's like event loop, or in JavaScript is the same principle. And the second condition is that there should not be running any kind of async task. This is the old documentation. The async tasks can be async tasks are handled by Espresso by default automatically, and it knows of how when to wait the async task and so on. But if you use the coroutines, the RxJava, or any other framework or library to do the asynchronous job, then we need to define the custom mechanism, and this will let the Espresso know that there is some kind of operation is running. But because it runs on the main thread, it doesn't know about any other threads, and we need to notify Espresso that, okay, wait on the main thread here, don't do anything, just block the call, and the another thread will stop, will finish the working, and then you can continue. And this is where the idling resource comes in. So idling by default means that you need the Espresso to be idle in that period of time during the waiting time. So the good practice is that don't use idle resource at all. So Android documentation mentions that you can use idling resource, but the good practice is that to keep uh, only the only testing, to keep all the testing stuff out of the production code, and leave all the testing stuff in a test code. But the problem is that the idling resource is by default I believe the API flow, and you mix the production code and test code automatically when you start using idling resource. And how idling resource looks like, it just you can imagine simple idling resource like that your code only will run if some kind of counter equals 0. So if there's zero, you continue to run the test. So the idling resource is like when you start your asynchronous operation, you can increase this counter by 1, and now it is equal 1. Your code will not execute testing code, and it will wait this idling resource to become the 0 again. And when your network operation finishes, you have the success callback and the error callback. In that callback, you just decrement the idling resource counter by 1, and you will get the 0, and your test then will continue to run. And the problem is that use idling resource and some kind of this monitoring tool in your production code, and it's not a very wise decision. The another option of resolving this is just use the constructor injection and inject the correct dispatchers that you can run those end-to-end tests with Espresso. So if it needs to run on the real environment and hit the data real database and real API, still the idling resource is not the best option, and we can define the another say mechanism to handle this. And why is that? Because the idling resource by default uses 5-second timeout to check the code. So when I mentioned that idling resource checks if your counter is 0, hypothetically, it means that it checks in every 5 seconds, and this is hard coded inside the idling resource, and you can't override. And it means that your code is very slow, and you can't do anything about it. So another solution is to write some kind of idling resource yourself, and you can check your code in every 100 milliseconds to 100 milliseconds. For example, if you wait some kind of animation, if you wait some kind of network operation, and you need everything to be connected to the real environment, and you can't fake or test double anything, you can just use this some kind of condition voucher and to check the resource, the code itself, the operation, much faster than the 5 seconds. And there is a really good library called Condition Voucher by Yazimo Labs, and you can check it. Also, talking about the Espresso, it's like we should mention the very popular library, the project Kaspresso, which is created by the Kaspersky, and it works with the UI Automator and the Espresso itself, and it takes out all the pain points from the Espresso, and it is very cool to use. So I know that I'm short on time, so I will just move on to this very good tools, the activity scenario and the fragment scenarios. The name suggests itself that activity scenario means that you can test. So actually, you can test the activity in isolation, and you can test the very specific features in your activity and isolate it from everything else. You can move to any state, like on created, on stop, on pause, so you can jump from state to state, and this will help testing very specific callbacks and state unit. And on the other hand, the fragment scenario does the same, but for the fragment, you can test how it passes the bundles. You can use a fragment factory. You can launch the fragment in container. So it means that you can launch the graphical interface of the fragment, and you can launch just a fragment without the UI, and it is much faster to test it. And in that case, it's like you don't need the emulator at all. So you don't need the emulator with the UI. You can use the headless emulator. It means that less memory, less CPU is wasted on your test, and you can combine those tests together, like some kind of test suite, which can run on the headless emulator and collect all the tests which needs the full support from the emulator. So it's a really cool tool. So yeah, this should be demo, but I believe I'm short on time. And to continue with the scaling, there are several options we can scale our test. It's like the Firebase test lab, AWS, and so on. You can set up your test farm as a device farm as well. But with Espresso, we can also use the test sharding. So what does it mean? It is like when you have, for example, 100 tests. You don't want to run 100 tests on each device and waste all those resources. Sometimes you need, but sometimes you don't. So you can just shard those tests, actually split them and run in parallel, 25 on each device, and it will run on parallel. It is hard to achieve. It's not the easy task, but still it's manageable. And there is a really cool library called Flank, and it will help you to guide in that way. And I will post all the links with the presentation. And what are the common challenges we have? The challenges by itself is the navigation. Navigation from one activity to another activity is a pretty common case, but from one activity to another activity, if you open the web view, if you open the Chrome tab, it's like Chrome custom tabs. If you have some kind of deep links between them, if you have really decoupled activity with the multi-module architecture, and you use deep links from module A to open module B, in that case, it is a challenge already, and your test should support it. And the analytics and backups are the hardest things to test. I can't stress enough how hard is it to test the backups. You need manual testing, and even with the Android 12 restrictions on the backups, I believe that it's one of the hardest things to test in the Android. So those are the resources which I will share it, but to repeat, we can choose the sharding, the Flank library will help it, the condition watcher will help to make the espresso much faster and stable, and there's links also how we can set up the emulator for testing, and how headless emulators can set up. So that was it. It was quite a brief overview of the espresso, but hope it will help, and it will help the test automation engineers as well in your company, because right now at our company there were plenty of test automation engineers which worked on Appium, and now they switched to the native testing frameworks because of the speed and stability. That was it. Thank you.